Hello, it's Church back here today with another video. Bet you didn't see that coming. First of all, I'm sorry that this video has taken so long to make. I've run into a lot of projects during this project, so it's taken me a long time to film. Now you may be wondering what the project is, or you've already figured it out by the title of the video, but my sister asked me to build a pig feeder for our pet mini pig. So I said yes, because I thought, hey, this would actually have a real world use, unlike some of the other projects I've done on this channel. What am I supposed to say? I hope that you enjoy the video. Alright, this is the shed where the pig hangs out. You take a look inside here. We've got this platform. I actually built the platform first. It's just a couple pieces of 1/4 inch wood that I've screwed together. The bucket's gonna sit on top of this, and then there's gonna be a hole drilled in here where the food can fall out. But before I put the bucket on, I actually need to work on the electronics and the code. So let's go look at that. So here's my setup here. We've got a servo, and this is going to be attached to the door that opens. Then we have a pressure sensor. So basically this Arduino in seconds is measuring out 12 hours. And so basically when it reaches that 12-hour mark, it starts taking data from this pressure sensor. So the bowl is going to be on top of this, and this pressure sensor is going to be measuring how much weight's on it. If it measures a certain amount of weight, which means that if there's already enough food in the bowl, then it doesn't open the servo. But if there isn't enough weight in it, it opens the servo and it continues measuring until it reaches that weight, and then it shuts the door. So if there's already even food in the bowl, it already knows how much more food to give. And then there are these two indicator lights. So these indicator lights basically tell us how much food is left in it. So if it's green, that means there's still a lot of food in it, but if it turns red, it means that it realizes that there's not a lot of food left and we need to refill it. I've actually changed the 12-hour count to only 30 seconds for the demonstration, and the amount of times it cycles through to only 2 times. So just for demonstration. So right now it's almost reaching 30 seconds, which would be it almost reaching 12 hours. And so it checks, it keeps on counting, because we don't want the time to get messed up, but it checks, and there's no pressure on this, but if the servo moved, it opened the door, the food would fall, I apply pressure to it, the servo moves back, that 2 right, it basically counted that's run through the cycle once. And so it's almost reached 30 again, and so this would be 12 hours later. Opens back up because there's no pressure on it, closes again, and it switches to red. That would mean that we've already run through all our food, and so we need to refill it. So it tells us we need to refill it. And then of course if I were just to apply pressure beforehand, which means there's already food in it, it just skips it and it goes back to the regular counting. So this is actually going to be staying outside permanently, and so I don't want to use an Arduino Uno because it's really bulky and big. I'm actually going to be using this Arduino Nano Every, and the whole system is actually going to be solar powered. So it's going to be recharged by a 12-volt solar system. Alright, now all the electronics are soldered on. I'm going to start working on the bowl now. So this thing is the base where the bowl is going to fit. So this is going to be buried underground. The pressure sensor fits into the slot, it slides in, and then basically the bowl, these 2 rods on the side of the bowl fit into these 2 slots, and it slides in, and then you have this third rod which actually comes in contact with the pressure sensor. When you apply more weight, it pushes on the pressure sensor more, and so it detects it. So the sensor's in there, and I have everything set up. Take the bolt, and so I have it set up so this green light will turn on when it reaches the right amount of weight, and I have the exact amount needed measured out right here. But instead of the light turning on, it would mean the servo turns it off. Alright, so this is the setup I have. We have the wires coming from the solar panel into the charge controller, and then we have a 12 volt nickel metal hydride battery that's also leading into it. These two outputs are going to be going to the power of the Arduino. Alright, so we've gotten everything set up. We've got the Arduino over here along with the indicator lights, the servo, base I guess, and then we have the charge controller and the battery. Once I plug this in, the Arduino will be turned on, but since I want the pig to be fed in the morning and 10 at night, I need to plug it in at that time. So I'm going to wait till tonight, plug it in at 10, and see what happens. Alright, so one of the things I actually hadn't considered when I first tested it is pig eats very aggressively, and that broke it. It actually broke this glue joint where these things slide in. So here's the new setup. So basically I have the sensor right there, and then this can pivot up and down, and it presses on the sensor, and so that's screwed into the wall. So this is a lot stronger. It's made out of wood and metal, and it won't break. So now I have to wait till tonight at 10, and then I'll plug it in. Ha! Here's what actually happened. So now I've fried my Arduino Nano. Now I'm going to be using an Arduino Uno. 12 volt battery I'm using might actually be a little too much power for the Arduino. Another problem. 5 volt pin Arduino cannot supply enough power for the servo that I'm using. Trying to use resistors to reduce 12 volts to 5 volts doesn't work at all. I designed and 3D printed Death Star. Now I've designed and 3D printed a TIE Fighter. Check out this bigger 3D printed Death Star. It's been a couple of days. This DC to DC converter has come. It's a 12 volt to 6 volt 3 amp converter, and I'm going to use it to power the servo. Alright, it just turned 8 o'clock. All I have to do is just press this button right here, and the whole thing is on. Now I'm going to need to check it at 8 o'clock tomorrow morning, and it's done. Alright, so it's 7:59. This is the first test. Should go off any minute now. Well, I broke my only pressure sensor, and I can't fix it because the wires are too thin. So this is my best attempt at making another one. Okay, so the last design didn't work because I designed it that when you would push on the thing, it would create more resistance, and apparently those pressure sensors actually work by when you push on them, it creates less resistance. But so this is the new design. So we have these two neodymium magnets with the wires coming off of them, and then we have springs that hold this bowl up, and so when the weight comes in, it pushes down and connects those two magnets, and so it completes the circuit, and so the whole system knows when there's food in the bowls. Final setup: the bowl that is on the spring system, and then we have the magnets right there, and then we have this fishing line right here that's attached here, and that's because there was some wobble in the system, and with the magnets having to repel each other, you can't have any wobble in the system. And then I can adjust the tension of the line by moving this screw back and forth. So I'm going to show you a full rundown of the entire system working. I'm going to have 30 seconds instead of 12 hours. Turning it on now. 30 seconds from now it should work. Alright, so I've been running into a problem for a couple weeks now actually. I'd hook the whole system up outside to the battery, and then I'd run it through a loop that waited 30 seconds as representation for the 12 hours. It always worked. But then when I would plug it in and make it 12 hours, which is 43,200 seconds, so I had an integer that would count up to 43,200 seconds by adding one each time and then delaying a second. For some reason, it would never actually go off. And so what I did is I brought my computer out to the shed. I printed out count, which is the 12-hour delay, and then I set the count to 43,200, and then I read on the monitor, and I found out that apparently 43,200 is too much. It overflows, and then it goes into like negative numbers, and so it was never actually reaching the 43,200 mark, so it was never actually running through the code to open the servo. So what I've done is I've actually made the delay for, instead of 1 second delay, I made it a 4-second delay, and then I've divided 43,200 into 4, and so now it's counting to 10,800, which is within the operating integer range. So I'm setting it to 10,790, and I'm going to be reading the monitor the entire time. So let's test it. It's actually working. So I'm going to wait 40 seconds to see if it actually works. This is the final test. I think I solved all the problems. Let's see if it works. It actually worked. Okay, you can't actually see it because the lighting's really bad right now, but it did fill up the bowl. So, I have solved the problem that I've been dealing with for a couple weeks now. Alright, so this is the second test. It's the next morning. Still works well. I'm really proud of this thing. It works perfectly. Emma, what are your thoughts on this product? Okay, thank you. On a scale of 1 to 10, 10 being the best, 1 being the worst, what would you rate this product? A 2? Last and final question, Emma. What feedback do you have on this product? Thank you for participating in this interview, Emma. It turned out well, I'd say. I built this project with the intent to keep it running out there, so now we don't need to like walk out at like when it's still dark at night and go feed the pig. It's just gonna make life a little bit easier, a little more convenient. Not that it's actually difficult feeding a pig anyway. Out of all the projects I've done on this channel, believe it or not, I think this one was the most difficult. It kind of took a lot of my pre-existing knowledge on how to build and engineer to make this project. I had to use a bunch of different aspects of engineering to get this to work. I had to do a ton of problem solving. I had to work with, power tools, but those are easy to work with. I had to do coding with Arduino, and I had to use designing in CAD and then 3D printing. It took a lot of my skills to get this project working, and in the end, it's just very satisfying seeing an engineering project that you designed and built and overcame all those problems to work. Anyway, if you're watching till the end of the video, thank you so much for watching. I put a lot of effort into this, so I would appreciate it if you were to leave a like and a comment, and if you want to, possibly even subscribe. Thank you for watching to the end of the video anyway. Thanks again, and I'll see you next time.